Hey everyone, welcome back to the Workplace Apprenticeship 20 videos. In this video, we're going to look at Lesson 2 from Chapter 4, which is looking at solving complex problems in the real world. So just to do a little recap from our last video, in order to solve problems involving right triangles, there's two little methods that we briefly looked at. The first one that we looked at was the trigonometric ratios, and that one there was, we had a little jingle called So Katoa. So really we want to use the trigonometric ratios when we're either given an angle or we need to find an angle. And then we can also use the Pythagorean theorem if we're only dealing with the sides. So we have two sides that are known and then we're looking for the third one. So there's no angles involved in the Pythagorean theorem. And just as another little reminder that this the side C here has to be your hypotenuse. Doesn't matter what A and B are, but that C value has to be your hypotenuse. So in A squared plus B squared is equal to C squared. This value right here has to be your hypotenuse squared. So we're going to be doing example number 2 from your notes today, and we will be practicing using some of these methods. So Elise is standing on the edge of a building. She can see that the angle of elevation to the top of the next building is 46 degrees, and the angle of depression to the bottom of the building is 62 degrees. So if the building is 30 meters away, how tall is it? So here we're looking for the height of the second building. And one thing, if you guys haven't noticed, that I like to do with most of my examples here is always draw a picture of what's going on here. So in our, I guess what's going on here is that we have Elise, she's standing on the top of a building. So here is one building here, and Elise is maybe standing right here. That's my awesome stick person. And then 30 meters away, we have this taller building that she's looking up at. So here's building number 1, here's building number 2. So what we know is that she can see the angle of elevation. So we're talking about elevation, you're looking up to the top of the building, and that one there is a 46-degree angle. So when we're talking about that 46-degree angle, it's usually going from some sort of horizontal line going up. So I'm just going to draw an imaginary little line here. And so this angle right here would be 46 degrees. And then we know there's an angle of depression, so we're looking down to the bottom of the building is 62 degrees. And same thing here, we're talking about angle of depression and elevation. It's always in terms of some sort of horizontal line going up or going down. So this one here is 62 degrees. So we want to know how tall is this building. So we're looking from the top of the building all the way going down to the bottom of the building. We can call that value X. We want to look for how tall that building is. So your next question might be, well, how on earth are we going to solve this? Or maybe you guys have also kind of realized what kind of picture I've drawn. But what you guys can kind of see here is that we have two right triangles here. This here is a straight horizontal line, and it's connected to this building, which is going straight up and down. So it's actually creating two right triangles here. And sorry, I guess I also forgot to mention or label this. We also have our buildings 30 meters away. So going from the bottom of one building to the other, this here should be 30 meters. So in order to solve this, what we're going to do is we're going to be looking for, this will be about a 3-step question. So what we're going to do is we need to find this total height, but we might need to break this into sections, because here we have two right triangles, and we have enough information to find the missing sides that we could total or find a sum to get our X value here. So we're going to find this height, which maybe I'll call Y, and then we can also find this height, which maybe I'll call Z. So one thing that we're going to do here first is we're going to look at, if you guys even want to, we can start off with looking at that angle of elevation. So we're looking at that top right triangle. So that top right triangle there, I'm just going to redraw this here. We know that had an angle of elevation of 46 degrees. And we need to know some other value to find that height, which I called letter Z. So in order to use, here we have an angle, so we need to use one of the trigonometric ratios, but we need to have another side. Where we have an angle, where we have an unknown side, but now we need another side in order to actually use that ratio. So let's go back up to our diagram. Now, in theory, this is assuming that our buildings are perfectly built, the distance from the bottom of your building should be the same from the distance at the top. So this length right here should also be 30 meters in our perfect world. Okay, so we can use this 30 meters here to and label that right at the bottom of that triangle there. And now we have enough information to try and use a trigonometric ratio. So now what I'm going to do here is to figure out what kind of ratio I should use, whether or not it's sine, cos, or tan. I'm going to label my sides, and that will help me out immensely for trying to figure out which ratio I should use. So this 30 meters here, it is not your hypotenuse, because your hypotenuse is across from that 90-degree angle, and so this side here is part of creating that angle, but it is not your hypotenuse, which means it's your adjacent. Then our other side here is across from your angle, which makes it your opposite. So here we have opposite and adjacent. So when trying to figure out which ratio we're going to use, we can look at using SO, CA, TOA. Here we have O and A. So going through each of those ratios, you will see that tan of theta, or the tangent ratio, would allow you to find that opposite value. So let's always start off by writing that formula. So we have tan of theta is equal to your opposite over your adjacent, and then we can fill in the information that we know. So our angle here is 46 degrees. So we have tan of 46 degrees. That's equal to your opposite, which is Z, over your adjacent, which was 30. Just like we discussed in our last video, you can write this tan 46 degrees over 1, and then you're just cross multiplying to solve, because you have two fractions that are equal to one another, meaning we can cross multiply. So we're going to write 30 times tan of 46. Remember, you always write that side first, that we don't confuse the angle and the side. And that's equal to 1 times Z, which is just Z. At this point here, you can put this into your calculator, and what we should find is that we would get a side, or a height, of 31.07 meters for that Z value. So we can go up to our diagram. If we want to, we can label this here. So this one here was 31.07 meters. So now what we need to do is, now we need to find the Y height, and we're going to use a very similar process. So for our second step, I'll write this over to the right here. So here we have a right triangle. It's going to be upside down though. So here we have that right triangle. We know that it had an angle of depression of 62 degrees. And we know that that length, so this horizontal length here, was 30 meters. So let's fill that in. So 30 meters. And then we're looking for that height going up and down, which we labeled that as Y. So then in order to figure out which ratio we're going to use, here we can look at labeling our sides of that triangle. So here we have across from that angle is your opposite. So Y is your opposite. And then here your 90-degree angle is in this top right corner. That's pointing across. So this here is your hypotenuse, which we don't have any values for that. But we do have our other side here, which has to be your adjacent. So if it's not your hypotenuse and it's creating that angle, it's one of the sides creating that angle, then it has to be your adjacent. So here we have our opposite and our adjacent. So once again, we're going to use that tangent ratio. So we have tan of theta is equal to your opposite over your adjacent. Then we're going to plug in those values. So we know that the angle is 62 degrees. So you have tan of 62 degrees is equal to your opposite, which is y, over your adjacent, which is 30. So notice here how these are actually very similar steps, but be careful. With this one here, we're dealing with different angles, so we will have a different answer. Okay. So once again, we're going to write this over 1 so we can cross multiply. So we'll find that we have 30 times the tan of 62 degrees. That's equal to 1 times y, which is just y. Then we could put that into your calculator. And sorry, I forgot to mention this last time, but don't forget, your calculator needs to be in degrees. So make sure you check for that capital D or maybe capital DEG on your calculator screen to make sure you're working with degrees and not radians or gradians, which are different units, so you'll get different answers. So anyways, so if you plug this into your calculator, 30 times tan of 62, we should find that our y height is 56.42 meters. So if you want to, we can go scroll up. We'll put this in for our value here. So we had 56.42 meters. And then so our final step here is to find that total height. We have a little chunk here of the height, and then we have the rest of it. So we have the total length. Now what we have to do is just add those two values. So our final step here, so step number 3, is to find the total height, which is our x value. So your x value is equal to, so it's the height of your z height plus the height of y. So you'll write 31.07 meters plus 56.42 meters. If you were to add that up, what we should find is that our total height is 87.49 meters. So then just to finalize the end of this question, we need to make sure we write a sentence for this word problem. So we could say the height of the building is 87.49 meters. So that is everything here for this video, and if you guys have any questions, make sure to come see me in class or text me on Remind 101. I'll do my best to answer any questions you guys have through text message. But with that, thank you guys so much for watching.